Hello, we are going to go over the review sheet for your assessment tomorrow, and my suggestion is that you pause the video before each question and do it before I go over it. For the first group, first question, you have two groups. The first group gets natural light, and the second group gets artificial light. Now, because you have two groups, and they are getting different things. They are not on a level playing field. That makes it an experiment. Observational studies are when both groups have the same setup. Now, you can have girls versus guys as long as they're both treated equally. In this case, they're not being treated equally because one gets a different type of light. For the next one, they want which one is least likely to contain bias. Now, people who are leaving a concert are going to have an opinion on their favorite musician. They'll probably say the person whose concert they just went to. If you ask people on a basketball team about their height, it tends to be that very tall people play basketball. So that's a bit of bias. And if you ask teenagers who use social media about their favorite communication methods, I mean, you guys know, you probably all have your favorite, whether you prefer Instagram or Snapchat or whatnot. So that's bias too. What's not bias is asking everyone leaving a grocery store about their political party affiliation, because everyone goes to the grocery store, not just Democrats or Republicans. You get a fair shot of asking everyone. They have nothing in common. For number 3, again, pause the video if you have to read it. They're asking for which one is a sample. Now, you're not going to ask sophomores about their yearbook opinions, and you're not going to ask just the athletes because, there's other people too. The most random thing would be asking every 12th student to enter the building. Now, I know a lot of people complain saying that if you enter the building, that could get sophomores and it could get freshmen who have no say in the yearbook, but it is the best option that we have here to choose from. You are not going to choose all the students in the school because that value represents the population. There we go. Moving on. For number 4, we are talking about a table of values, and they want you to find the mean number of days absent. So, in order to find the average, you need to put this in your calculator. These two columns have something in common. They are related to each other. So we're going to have L1, and you're going to have L2. So L2 is what we call your frequency table. And your frequency table stands for how many times the other point of data happened. For example, 1 happened 64 times. 4 days being absent happened by 4 students. So we're going to put this all in the calculator, and you're going to go to Stat, Edit, and you're going to put all of the values in L1 and then all of the values in L2. I highly suggest that you pause the video while you're doing this and try it on your own. So double check you made sure that you put them all in correctly, otherwise you won't know if there was a mistake. If you get an error, it's probably because your two columns are mismatched. Make sure they have the same number in each. And if you still get an error, make sure you didn't put the subtraction button instead of the negative if you have a problem that requires a negative. If you had trouble putting in your numbers and you needed to clear a list, you are going to highlight the list you want to clear, and you're going to hit clear, enter. Anyway, now that you have your numbers in there, you're going to go to Stat, Calculate, and we are going to do one variable statistics. I have L1, but I also used L2, so you need to make sure you put that in there. In order to get L2, you are going to hit second, number 2. Now, X bar, the very first thing up there is going to be your mean. So if we have to round to the nearest tenth, that is going to be 1.0. Do not just put 1. If you put just 1, you're going to lose a point because it said round to the nearest tenth, so you need that extra decimal point of 0. They're asking for your population standard deviation, so that is going to be sigma, which is the sideways fallen over p. And if you go to that in your calculator, that value is 1.76377. It kind of looks more like a little circle on your calculator. So that is going to be about 1.8. And then the very last one asks for your sample standard deviation. And the sample is S sub x, S for sample. Go back to your calculator, and our sample standard deviation is 1.766. Which also rounds to 1.8. Just coincidence that they happen to be 1.8 both when they're rounded. Now, I just want to point out that for this particular problem, you were talking about the findings of all 284 freshmen. And because you're finding the findings for all of the freshmen in the school, you really should stick with the population standard deviation. Questions will tell you whether it's population or sample. You just need to know the difference between the two symbols, but it does make more sense to use population here. On to the next page. They want you to describe the shapes. Now, there are 4 main shapes that we tend to use, one of them being symmetric, although there are 2 types of symmetric. Now, forgive me, I'm trying to use a really bad stylus, so my writing is not coming out perfectly. It is symmetric. You can also say that it is the bell curve. Oh, this stylus is even worse. How do you people write with these? Okay. Bell curve, or you may call it the normal distribution. That's supposed to say normal, does not look like it, but we're going to move on. The next one is being skewed. So that means it's not level or symmetric. Now the tail is on the left. It's being pulled towards the left, so we say it is skewed left. On the flip side, the tail of the other one is being pulled to the right. So we say this is skewed right. Again, this one is symmetric, it is a bell curve, it is normal. This one is heavily skewed right, because the tail is on the right. Now, for part F, this is also symmetric, but it has a fancier word for it. This is not normal. It is not a bell curve. This is what we say is bimodal. Okay, remember to pause the video if you need to do these questions on your own first. For number 6, it's asking which one has a greater standard deviation. A standard deviation is approximately, on average, how far away are you from the mean? So the larger your standard deviation, the more spread out you are from the mean in the center. So this one goes from, I want to say 0.44 to 0.60. That's a range of, you're increasing by 0.16. However, dot plot B goes from 30 to 0.75. Now that is a range of 0.45 it's increasing by. So I would say dot plot B has the greater standard deviation because it has a greater range, or because it's more spread out. And either of those explanations would work. I'm just not going to write them because the stylus stinks. Okay, let's keep going. For number 7. All right, the key word here is that they are normally distributed. And when something is normally distributed, you can draw a normal distribution. And in your normal distribution, the mean goes in the center. I'm using mu for mean because a normal distribution, when you're talking about the population, not the sample of X bar. They're also telling me the standard deviation, again, population, is 4. Now read what they actually want you to look at. They're talking about having temperatures above 90. So 90 on your graph is here. And to be above 90, we are shading to the right because that's where numbers get larger. So that means you need a lower and you need an upper bound. Your lower and upper are the numbers based on the shaded region. So of the shaded red region, the smallest number is 90. Now, ideally, for upper, we don't really have an upper. This goes up to infinity, but you can't type infinity in on the calculator. So instead, we are going to go up to 1,000,000. You're just going to pick a really large number. It doesn't necessarily have to be 1,000,000, it just needs to be super large. I mean, we're talking about temperatures. There's no shot that it's going to be 1,000,000 degrees Fahrenheit outside. So 1,000,000 is large enough to encompass all of the data. And what you're going to do is put this in the calculator and get out what proportion of days are above 90 degrees. In order to get this, we're dealing with a distribution. So we're going to go to second vars, because right above vars is DISTR, stands for distribution. And you are choosing normal CDF. Your lower was 90. Your upper was a lot. You could put 1,000,000 or however many zeros you want to put there. It does not matter. Your mean was 84. And your standard deviation was 4. You are going to hit paste, enter, and you get 0.0668. Now, the more decimals you put, the more accurate your answer is going to be at the end. So if I were you, put several decimals to begin with, that way your final answer is more accurate. Anyway, that means 0.06, that's about like, it rounds up to 7%. About 7% of your days in July are more than 90 degrees. Now, they're not asking for the percentage, they're asking for how many of the 31 days. So you need to find like 7% of 31. So I'm going to multiply by 31 to figure out how many days. And that's going to be approximately, if you round, 2. Moving on. I highly suggest you pause the video to actually read this question and then resume it. That way we can go over it. I'll be honest, I didn't even read the question. I'm just going to go straight into it. I see that they want a 95% confidence interval. And I know that that is my center plus or minus your margin of error. Now, your margin of error is twice your standard deviation. And I have my standard deviation from the computer simulation. If you have a box, or this isn't really a box, if you have data in the distribution, that's where you're actually going to use your data from. It does not matter what it says at the beginning of the question. You use the data from the computer in the graph. So if you guys were to find your standard deviation, 2 times 0.066, that's the best that I got. If you were to multiply this, your margin of error becomes 0.132. Your center is your mean. So I'm going to do 0.602 plus or minus 0.132. Now, if you're just sitting there, take your calculator and subtract 0.602 minus 1.32 is 0.47. Now you're going to add 0.602 plus 0.132 is 0.734, but they did ask you to round to the nearest hundredth. So you're just going to write 0.73. There's your interval, the middle 95% of your data. I mean, look at it. As you go from 47 to 73, that seems like 95% of all of the data. Now they're asking, members of the prom committee are concerned that a vote of all students attending prom may produce a 50-50 split. So they want to know what evidence supports their concern. 50% is 0.5, and 0.5 is right here. It is inside your confidence interval, is where all the action's happening. It happens more than 5% of the time. So we say that it is possible because 0.5 is in the interval. Moving on to the last one here. To determine if the type of music played while taking a quiz has, I'm not reading this, you guys pause it and you read it. So for number 9, to determine, let's see, John correctly rounded the difference of the means of his experimental group as 7. How did John obtain this value and what does it represent in the context? So you basically need to say where the number 7 came from. He said the difference of the means. That means he found the mean of both classical and rap and then subtracted them. Now, again, I'm sorry for my really bad stylus, but I am trying to write he found the means of both groups and subtracted them. What does it actually represent? It represents represents on average. That's very important to say on average because we're talking about means, not exact values. So on average, the classical group scored 7 points more. You could say that in different ways. On average, the people who listen to classical music scored 7 points better on their quiz. On average, the people who listen to rap music scored 7 points worse. It's up to you how you would like to write it. Okay. Now we want to know if getting a 7 is significant. So it says, does the simulation support the theory that there may be a significant difference in the scores? Now we're talking about 7. 7 is all the way over here. Honestly, it looks like it's at the very end, like it would be outside of the 95% confidence interval. So I would say if I had to guess, it is significant. Something is significant if it happens less than 5% of the time, or if it is outside of your interval. Now, you don't have any data, like where is the box telling me my mean and my standard deviation? It's not there, so you can't figure out the confidence interval. What you can do is count. Does this happen less than 5% of the time? You are going to start at 7 and go to the closer end. We are closer to the right end. So I'm counting all the dots, 7 and above. That is 4 dots out of how many? 250. So 4 divided by 250 is 0.016. That means you happen 1.6% of the time. If you rarely happen, it is significant when it does because we did not expect it. It is unusual, unlikely, significant. So we're going to say, yes, it does support the theory that they are statistically significant because it happens less than 5% of the time. And I think we're done. Good luck.